In many branches, a compressor is the heart of a complex process. And if the heart stops, the whole process is interrupted. This will cause losses. So when your process is depending on a compressor, you want a reliable and professional business partner.
Howden Compressors in Rheden, the Netherlands, is a worldwide leading company in design, engineering, producing, assembling, servicing and maintenance of compressors for the oil and gas industry. A reciprocating compressor consists of a frame, a crosshead guide and a cylinder. The moving parts are the crankshaft, connecting rod, crosshead, piston rod and a piston. The piston is equipped with PTFE-based rider rings which bear its weight. The piston rings act as a seal between the high and low pressure side of the cylinder. Depending on the process, the piston may be lubricated or non-lubricated. For non-lubricated compressors, process gas conditions accelerate rider ring wear unpredictably, in a way similar to the action of an eraser. After years of research with marginal improvements in material, Howden Compressors developed a revolutionary new design, the free-floating piston. The principle of this technique is that the process gas itself carries the weight of the piston. During the compression stroke, it fills with process gas. Due to the pressure difference, gas flows out at the bottom, ensuring there is no physical contact between the rider rings and cylinder liner. Wear is thus reduced to practically zero, resulting in much longer rider ring lifetime. The design of the piston has also been specially adapted. The rider rings are now relocated in between the piston rings to create a constant pressure. Regular compressor valves that react to differences in gas pressures are located in the piston face, enabling gas to enter into the piston. Flow nozzles have been integrated in the rider rings and a profile machined on the lower surface to create a bearing layer beneath the piston. As the thickness of the bearing layer is in the order of microns, the flow required to lift the piston is marginal compared to the compressor's capacity. The new construction compensates for this, so net compressor capacity is unaffected. After the design had been subjected to rigorous in-house dynamic testing, a successful pilot test followed in a production hydrogen compressor at the customer's site. The key advantages of the free-floating piston include practically no rider ring wear, increased lifetime of piston rings and stuffing box elements, and no need for cylinder lubrication. The design can be applied to existing compressors, and it is fail-safe. Maintenance costs are reduced, while reliability and availability are increased. So far, we have fitted 200 free-floating pistons to new-built and re-rated compressors. What's more, as at June 2010, the first free-floating piston compressor has clocked up 80,000 hours on its original rider rings. Putting the principle into practice. Howden Compressors, free-floating piston technology.